Energy is something that you experience daily. Sometimes you can see it, sometimes you can feel it, but sometimes you cannot. Energy is the ability to do work or to produce heat, like these two girls are doing. They are chasing one another down the hall, their body working in order to move. Heat is being produced as they run. Their body temperature is increasing.
I'm gonna get you. No, you won't. Yeah. I will. Oh, rubber band. Ah!
Energy is classified as either potential or kinetic energy. Energy will always be classified in one of these ways. Potential energy of an object is due to composition or position, showing the possible energy that could come. Kinetic energy of an object is due to the motion of the object. The energy is shown through the object's movement. These simple actions all portray both potential and kinetic energy. With the rubber band shooting, while the rubber band is stretched, you can see the potential energy of the rubber band. And when it is shot, the kinetic energy is shown.
Oh, snowballs. Ah!
This simple action illustrates two main things. One being one of the most important characteristics of energy, the law of conservation of energy. This law states that energy can be converted from one form to another, but can neither be created nor destroyed. The amount of snow in the snowball and the amount of water from the melted snow is the same. Energy is being converted from one form to another, but there is the same amount. The melting of the snow also shows a type of energy process. This specific example shows an endothermic process. Energy in the form of heat is flowing into the snowball from its surroundings, the hands.
Ouch. Are you okay? Yeah.
This action shows an exothermic process. Heat is flowing from the steam of the water and into the system around it, including Shalice's hand.
Yes.
Water boils at the same temperature no matter what. This temperature is 100 degrees Celsius. To reach this temperature, it takes energy. We can figure out how much energy it took. In chemistry, we learned that the specific heat of water is 4.184 joules per gram degrees Celsius. If we know the temperature of the tap water and how much we had, then this is a simple math problem. You can see that the temperature of the water straight from the tap was 37 degrees Celsius, and the amount of the water was 250 milliliters, which is the same as 250 grams. Now all we have to do is plug into the equation Q equals mc delta T. Q stands for the energy required, M stands for the mass of the substance, C is for the specific heat, and delta T is the final temperature minus the initial temperature. Q is the variable we're trying to solve for. We know that the mass is 250 grams, and the specific heat is 4.184 joules per gram Celsius. The temperature is easy. We know that the final temperature is 100 degrees because all water boils at that point, and we just measured the initial temperature. See? It is that simple. Now all we have to do is solve this equation.
burn my tongue.
Oh, let me go get you some ice to cool it off.
This is yet another example of an exothermic energy transfer. The heat from the hot chocolate is being released into its surroundings, or Shalice's mouth.
Much better.
The hot chocolate and the ice cubes have very different temperatures, so another energy transfer occurs. The ice melting is endothermic because it's taking energy from the hotter liquid surrounding it. The hot chocolate is somewhat less than 100 degrees Celsius now because it has released some heat, and the ice cubes are at 0 degrees Celsius, the freezing temperature of water. The ice is going to melt due to all of the heat surrounding it, but the ice will release the coldness contained in itself, cooling down the drink. If we were to have the same amount of ice in hot chocolate, we would get the new temperature by simply finding the average. We know that the hot chocolate is being cooled off, but since there is not enough room in these mugs for an equal amount of ice, we are not sure by how much it is being cooled off.
That was good hot chocolate.
No matter what they do, energy is always present and necessary. Energy is such a huge part of our lives, and you will never live a day without using energy.